So here is the second part of the class opener, number 5. We are going to multiply everything by the LCD. Do you guys want to get rid of all of them at the same time by multiplying by the LCD, or get rid of one of them at a time? All of them at the same time. All right. So what is the LCD? Remember, to find your LCD, you're really asking yourself, what could I change this guy to that I could change this guy to that I could change this guy to, right? So there's definitely an X here and an X there, so X is definitely involved. What about the 2 right here? We'll just put that 2 on the LCD. And what about this complete binomial X plus 7? You have to put that also right there, X plus 7. So your LCD is really 2x times x plus 7. And if you write that LCD on the numerator portion of each of these fractions, you'll be able to cancel out all fractions at once. Check it out. If you take a look at that first fraction, the 2x completely cancels out with the 2x. So what is left? There's 1 times x, 1 times 7, so that's just x plus 7. I'm going to bring down this plus sign. So I have a plus sign right here. And now the second or the middle fraction, what ends up happening is that the x plus 7 cancels with the x plus 7. So what's left over? A 6x. Bring down the equal sign. And on the final third part over here, the right side of the equation, the x up here cancels with the x down here. So what do we really have left? This is where it gets a little tricky, because we really have a binomial, which is x plus 7, times the number 2, and times the number over here, which is negative 1. So you might as well set up this problem by taking the 2 and the negative 1 and putting them together and making it a negative 2 times the x plus 7. Does that make sense? So what do I really end up with? I end up with a negative 2x minus 14. So of course you want to simplify each side, or simplify anything possible. You have an x here and you have 6 of them there, so that's a total of 7 x's. So you have 7x plus 7 equals negative 2x minus 14. And if we continue to solve, we're going to add 2x, cancels, add 2x. You're going to have 9x plus 7 equals negative 14. Which means that if you subtract 7 here, subtract 7 there, you're going to end up with 9x equals negative 21. And your final step would be to divide by 9. And x, or 21 divided by 9, it doesn't work, but you could reduce it by 3. So you end up with a negative 7 over 3 as your final answer. What do you guys think? And of course, you could always, or you should always, make sure that that answer doesn't give you a 0 in the denominators, which you know that in this case it does not. So in addition to studying the homework, which is solving equations that have fractions in them, you should also go back and study maybe last week's test, because we're also going to throw in some simplification, right? Like on number 1 right here of last week's test, you're supposed to factor anything possible. So if you factor out a 2, you're going to have x minus 2 left over on the inside. And on the bottom, if you were to pull out a 3, you'll also have an x minus 2 on the inside. So of course the x minus 2 cancels and your answer is 2/3. That's just a little bit of review, because a couple of these, I'm talking maybe 1 or 2, will pop up on tomorrow's test. So that's also simplification. I'm just going to pick some at random from last week's test, and we'll see. Like this one right here is the factoring by grouping. You might have some of that. Maybe sum or difference of 2 cubes. How do we do this one? Well, the sum of 2 cubes requires the sum of 2 cubes formula, which is a cubed plus b cubed equals, and here's the actual formula part, a binomial times a trinomial. And remember, if it originally had a plus, which right here it does have a plus, then your binomial is going to start with the plus in the middle, which means that your middle term over here is going to be a minus. Now, if this were a minus, then your first binomial would have a minus, and this would be a plus. The middle term would be a plus. So it's that easy. Be careful. It might be sum, or it might be difference of two cubes on tomorrow's test. And it might not even be on there. But, yeah, right. You know it's going to be on there. I'm recording this, so make sure you got this down. So all you got to do is first identify what your perfect cube terms are. So right above the x to the third, what would belong in here that'll give you an x to the third? Well, obviously that would be an x. And what would belong in here that would give you an 8? Obviously that's going to be 2. And that just tells you what your a value is and your b value is. That way when you plug it into your formula, why did I circle that? I don't know. But you're going to be plugging in the x for a and the 2 for b. So let me rewrite my whole fraction down here, but instead of that original sum of two cubes, it's going to be a binomial times a trinomial. So a plus b, that's just simply going to be x plus 2. And then we also have a squared, which is x squared. And then minus a times b, which is 2 times x, or x times 2, which ends up being 2x. And then at the very end, plus b squared, which is plus 2 squared, which is 4. I might as well do the 2 squared and change it to 4. Now on the bottom, as you could see, you might think that you could factor that, but you really can't. What times what is positive 4 that if you add together is negative 2? It doesn't work. So all you do is rewrite it. X squared minus 2x plus 4. And because you have the same quadratic trinomial on top and the same quadratic trinomial on the bottom, those cancel out. And your final answer for number 5 on last week's test is simply x plus 2. Now, I will give you this as a warning. If I do, no, I will. I'll put this on the test, but I'm probably going to change maybe a sign or 2, or maybe the 8, maybe change it to a 64. I don't know, something other than 8. I can't give you the same exact question. Actually, on some of them I do. What else did we do last week? We have a multiplication of two fractions. So right here we're not solving, it's not cross multiplying because it's not an equation that you could solve. You're not trying to get rid of fractions, absolutely not. It's just canceling, factoring and canceling. So if you did factor, you'd have a 4 parenthesis x plus 4 up here. We'd have x plus 3 x minus 1 right there. And down here you have a 2 parenthesis x plus 3. And over here the x plus 4, you can't do anything with it. So if you take a look at what we have, well, the x plus 4 on top cancels with the x plus 4 on the bottom, the x plus 3 with the x plus 3. The 2 with the 4 will cancel out. You have a 2 left over up on top. So your final answer is 2 on top with the x minus 1 right next to it with nothing on the bottom. So that's your final answer, which you could also write as 2x minus 2. Again, I'm just picking these at random from last week's test. It doesn't mean that that question is going to be on tomorrow's test. So there will be some simplifying where you just factor and cancel. There will be where you have to use a sum or difference of two cubes. There will be where you just factor and cancel because it's multiplication. You do the same thing. There's going to be some division ones. For example, number 8. How do we do that? Well, let's first factor anything possible. X squared plus 5x will factor to what times what is negative 6, that if you add together is 5. That'd be a positive 6 and a negative 1. Okay? Again, I'm not going to give you the same exact questions. I'm going to change some values, so make sure you just understand the process. What else could we factor? Well, down here we have x squared minus 2. If you pull out an x, you'll have an x minus 1 left over. Anyhow, don't forget that this is division, which means we need to rewrite the whole thing. The top, or not the top, but the left side of this expression, notice that it didn't say equation because it does have an equal, it does not have an equal sign. We're not solving. The left side of this expression is not going to change. It's going to be x plus 6, x minus 1 over 4x. Change it to multiplication. Flip the second fraction. So the x plus 6 that's on top is going to be an x plus 6 that's on the bottom. And what I factored, x times x minus 1, will now be on top, x times x minus 1. And now you could go through and cancel out anything possible. And you might make the mistake of thinking that you could cancel out the x minus 1 with the x minus 1. You can't do that because they're both on top. The only way something will cancel is if you have something on top that's identical to what's on the bottom, like the x plus 6. Or not only that, we could also cancel out this x on the 4x and this x that's out in the front. Those guys could cancel also. So what's left over? We have x minus 1 times x minus 1 over 4. So you could write that as a final answer, x minus 1 squared over 4, if you wanted to write that. Like I said, I'm not sure if I'm going to pick this question for tomorrow's test, but there will be some of last week's test on tomorrow's test. So let me see, we've simplified, we've multiplied, we've divided. Let's also add and subtract. And of course, when you add and subtract, you need a common denominator to do that. So let me just jump to number 13. I don't know. Again, I'm just picking these at random. Now, this is not an equation, so you can't start canceling out fractions by multiplying by the denominator or the LCD. No way, there's no equal. You're not solving, you're simplifying. So I'm asking you to subtract these fractions. In order to add or subtract fractions, you need a common denominator. So what's the common denominator going to be? Well, what times what is 4, that if I add together is negative 4. It's negative 2 times negative 2. So inside your parentheses, you're going to have an x minus 2 and an x minus 2. Now that works out great because that is the LCD, because both of these guys, this one and this one, could both change to x minus 2 times x minus 2. So I'm going to rewrite both fractions with the x minus 2 times x minus 2. On the final answer, I'll write that as x minus 2 squared. But for now, I'm just going to bring that down. And then I'm going to ask myself, how do I change this first one to become this one? Well, it is. This one is this one. It's just factored, right? And how do I change this one to become this one? Well, it's missing x minus 2. So I need to multiply both top and bottom by x minus 2. So on the right side of the equation, 3x times x, that's 3x squared. And 3x times 2, that's plus 6x. Now, on the left side of the equation, we said that we didn't have to do anything because this really is this. It's just factored. So that 7 up there is just going to come down. Anyhow, for my final answer, I will have the x minus 2, and I might as well write it as squared. And I have all these terms that I need to combine. But remember, this minus sign belongs to the whole numerator, which means that this minus sign actually gets distributed to both terms. And if I want to put it in order, it will be a negative 3x squared as my first term on the numerator. And then the minus 6x, again, I said the minus gets distributed to the positive, so that becomes a minus 6x. And then the 7 is actually a positive 7, because it was always a positive 7 out here in the front. And that's my final answer. There's nothing else to do. Yeah, you're supposed to try and do Jaime Escalante method, but if you start thinking about a times c, that's negative 21, and what two numbers combine together to give you negative 6, that if you multiply give you negative 21, it doesn't exist, so it's no longer factorable. So this is your simplified expression. Notice that I didn't say this is the answer. I mean, it's the answer for this question that I'm asking you, but it's not like a solution because this is not even an equation to start with. It's an expression. So that's about it, guys. We have a large test tomorrow. Most of it is on solving equations, but some of it is a little bit of review from the past test, which you just saw right now.